Okay, I'm going to go over the practice quiz, and the real quiz will be really similar. I just wanted to make sure you can go through all these things and understand sine, cosine, tangent, all that stuff really well. Okay, first, these are all things you should have memorized. It's not that hard to figure this stuff out and then just kind of know. It really helps. And of course, you don't have to memorize it, but it's good to have these things right on the tip of your tongue. So that's why I made this chart here. So first, let's look at our unit circle, which you should always draw. Draw it like for every problem practically. Okay, there's our circle. And we know that sine is the y value. So y is sine. The full word is with an e at the end. Normally when you write it as a function, you don't put the e at the end. It's kind of weird. So anyway, so y is sine, right? So that's this way. And then x, of course, is the cosine value. That's this way. And our circle is radius 1. So sine, you start here. You always start right here, and you go around the circle counterclockwise. So sine starts at 0. Remember the y value. There's no height above the x-axis here. So sine of 0 is 0. Now let's do the easy one. Pi over 2 is like 90 degrees. And if that bothers you, let's write that above here, 90 degrees, so you can remember that. 90 degrees, sine is 1, right? The y value is the biggest it can be. So sine is 1, and in between it goes from 0 to 1. So these are the numbers here that you should know. These are the most common ones. Pi is like 180 degrees. So pi over 6 is 30 degrees. So I can write that above here if that helps. Pi over 4, 180 divided by 4 is 45 degrees. So that's 45 degrees. And pi over 3 is twice pi over 6, or 180 divided by 3, which is 60. So that's 60 degrees. Okay. Yeah, my voice is doing swell. Later in this quiz, we're going to show these answers. It's really easy to work these out, what 30 and 60 degree are. But you can imagine as we go around at 30 degrees, right about there, sine ends up being about halfway up. It ends up being about halfway. When you get to 30 degrees, the y value is about halfway up. So less than halfway around the circle, the y value goes up because the circle changes fast in the beginning, right? It's rising straight up here, and then it slows down towards the top. So sine of 30 is 1/2. Or you could write 0.5, whatever, I'll write fractions. Sine of 45 degrees, that's halfway in between. That's exactly the same as cosine. That's where they're the same because it's an isosceles triangle. The opposite and the adjacent are the same. At 45 degrees, opposite and the adjacent are the same. And that one we're going to show later on, and this is why I say perfect answers. That is the square root of 2 over 2. That number comes up a lot, square root of 2 over 2. If you see a decimal in your calculator, and you should know that the square root of 2 divided by 2 is like 0.707, goes on forever. But if you ever see 0.707, you think, oh, that's square root of 2 over 2. Square root of 2 is 1.41, goes on forever. Divide that in 2, you get 0.707. Okay, then sine of 60 degrees, then the opposite is bigger than the adjacent, so the answer is also bigger than that, and that's just the square root of 3 divided by 2, which we'll show that later on in this quiz. And then it goes to 1. Okay, so it goes from 1/2, square root 2 over 2, square root 3 over 2 to 1. Now cosine is like very similar, right? But it starts differently. Cosine starts off at 1. So it starts off at 1, starts off at the biggest x value. And then remember we're measuring the x value. As you go up, it doesn't change very fast. And at 30 degrees, it's this one. It's the same as sine of 60 degrees. It's the square root of 3 over 2. Here they're the same. Square root of 2 over 2. Here it's 1/2. Sine of 60 degrees is 1/2. When you get up to here, the x value is exactly 1/2. And then here it's 0. So it's just taking the sine ones and going the other way, right? So cosine starts here and goes this way, and sine starts here and goes that way. So if you know one, you know the other one. And then, so if you know one, you know this one, and then you also know this one, because tangent is the same as sine divided by cosine. So all you gotta do is take this divided by that. 0 divided by 1 is 0. 1/2 divided by root 3 over 2. The bottoms cancel, so we just have 1 over root 3. Okay, this is 1 over root 3. If you don't like leaving roots in the bottom, you multiply the top and the bottom by root 3. So that's the same as square root of 3 over 3. Here we divide them. Root 2 over 2 divided by root 2, that's the same thing, right? Same thing divided same thing, so that's 1. Which makes sense. Tangent of 45 degrees, isosceles triangle. The opposite and the adjacent are the same, because tangent is also opposite over adjacent, so it's 1. And then tangent gets bigger. Root 3 over 2 divided by 1/2. The halves cancel in the bottom, so that's just square root of 3. So here it's 1 over square root of 3, and here it's a square root of 3. And then 1 divided by 0 is infinity. So you can say infinity, you could say undefined, but yeah, either way. Okay, so again, all you gotta know is sine, and then you know cosine, and you know tangent. So it's kind of cool. Okay, now let's do some practice here. Radians. I said you should be able to do these out of calculator, no decimals. 285 degrees is the same as 270 plus 15. 270 is right here. That's 3 pi over 2. That's 3 pi over 2. So that's 3 plus, why I left some room down here for you to write. So that's 3 pi over 2 plus 15 degrees. Well, let's see. 30 degrees is pi over 6. So 15 degrees is pi over 12. So, right, so if I write that down here, so 30 degrees is pi over 6, so every 15 degrees is half of that. So half of pi over 6 is pi over 12. So we have here 285 is 3 pi over 2 plus pi over 12. Okay, it's got to do some fractions here. Let's multiply the bottom by 6, multiply top by 6. That's 18 pi divided by 6. Did I do that right? Yep. 12 divided by 12 on the bottom here. 18 pi divided by 12 plus pi over 12, so that's 19 pi over 12. So this is 19 pi divided by 12. Okay, see, didn't need any decimals. You can figure out the exact answer. This 11.25 looks kind of weird, but if we multiply that by 4, 4 times 11.25, that's 45 degrees, which is pi over 4 radians. So this is 1/4 of 45 degrees, and so that's 1/4 of pi over 4. So 1/4 times pi over 4 is pi over 16. So this is pi divided by 16 radians. And then 300 degrees, let's see, that's the same as 360 minus 60, which is 360 is 2 pi. So that's 2 pi minus 60 is pi over 3. 180 divided by 3 is, yep, so minus pi over 3, because pi is like 180, 180 divided by 3 is 60. 2 pi minus pi over 3, 2 pi is the same as 6 pi over 3 minus, let me just write this out. So multiply top and bottom by 3, that's the same as 6 pi over 3 minus pi over 3, which is 5 pi over 3. So this is 5 pi divided by 3. Okay, see, didn't need a calculator. Now, if these were weird numbers like 284 degrees, yes, then you do use a calculator. And if you remember, the way you calculate them is you go, if you want radians, you multiply by pi over 180. And if you want degrees, you multiply by 180 over pi. Whatever you want's in the top. Pi radians is the same as 180 degrees. So you can, but anyway, here we didn't have to. We get the perfect answers. Okay, now here you have to use a calculator. Okay, 1 radian. So again, you multiply by, we want degrees, you multiply by 180 divided by pi. So multiply by 180 divided by pi, then you get the degrees in the top, which is what we want. The radians cancel. So this is calculator work. This one is just 1, right? So 180 divided by pi, and again, just keep a reasonable amount of decimal places. I get 57.3 about. So 1 radian is the same as about 53.3 degrees. It's too bad it's not a pretty number, but you know, pi is not pretty, so. But that's what a radian is, about 60 degrees roughly. Okay, 0.6, again, you just go 0.6 times 180 divided by pi. I get 34.37, let's say 34.4, roughly 30.44 degrees. And then 20 radians, that's going to be a lot, right? Because 2 pi, about 6.28 radians is 360 degrees. So this is going to be like 1,000 degrees or something. So 20 times 180 divided by pi, 1145.9 degrees. Put a little degree symbol there. All right. The inverse functions. Okay, what you need to know is the inverse of sine. Okay, then here's a weird thing. They're not really inverses. They're inverted functions. It's 1 over it. It's not. It's really bad notation and bad words for it. It's yeah. Usually the inverse of sine you write as sine of -1 of x is the inverse sine. That's what chapter 20 is about. Here we're just 1 over sine. So 1 over sine you would think would be cosine, because 1 over tangent is cotangent. Okay, that's the same thing. But 1 over sine is not cosine. The inverse of sine is, and I remember the way I remember there's always a co in every pair. So it's not secant, it's cosecant. So cosecant x, because sine doesn't have a co in the word, but cosecant does, so there's always a 1 in each pair. And then 1 over secant is cosine. Again, there's a co in the cosine, so secant there isn't, so that's cosine. So they're inverted functions, not inverse functions. It's kind of weird. Okay, and if you know those, you know all of them. 1 over secant is cosine, 1 over cosecant is sine. Yeah, the ones you use all the time are sine, cosine, and tangent. If you have those, you don't really need the other ones, but the other ones can be convenient for math reasons. Okay, here, like I said, I sent out this is draw a sine curve. It's like draw any curve. I guess you could do that, but let's draw a sine curve. Now again, we can do this without even, just by looking at the unit circle. Sine is the y value, starts at 0. And and I say go to 2 pi, so let's mark it off. So let's say here is pi, here is 2 pi, so here's pi over 2, and then we got to go back this way here. So here's pi, negative 2 pi, negative pi over 2. Okay, sine starts at 0. The y value when you start 0, and it goes to 1 at pi over 2. So it starts at 0 and goes to 1. So let's make 1 about right there. So there's 1. And sine of pi, back to 0, and then we go to -1 at 3 pi over 2. That's right here, so it's -1, put some right there, but -1, and then back to 0 at 2 pi, right? We go all the way around at 2 pi, we're back to 0, no y value here. And then the same thing on the other side, it's symmetrical, so then you try to, draw a nice curvy line here, connect the dots like this, and then same thing here, it's -1, back to 0, so it goes like this. I did something wrong. It's -1 at pi over 2, not at pi, it's 0 at pi. I should put the dots here. So here it's -1, and then here it's 1 again. So it goes like this. I can fake it a little bit. Like this, like that. And it goes on forever. We'll just draw, it keeps going. Of course, I just said 0 from 2 pi to a full cycle. Okay, so 1 period is 2 pi. It starts going up to going up. Okay, so yeah. Now a cosine wave, if we drew a cosine, we would start it at 1. So it'd start up here, and then it goes to 0 right here. So 1 to 0. So a cosine would look like this. Okay, so it's just a sine wave that starts a little bit earlier. It starts at 0. Our sine wave starts at pi over 2, at least if we call the peak the start. Or if we call this the start, which is more typical, where it starts going up, the cosine wave starts at negative pi over 2. It's pi over 2 behind. Pi over 2 behind. That's why we can say that sine of theta is the same as cosine of theta plus pi over 2. Because remember, add pi over 2 means we shift it to the left. We're shifting it to the left pi over 2. Because plus, remember the x value, plus is always the opposite what you'd think. And the y value, we would be doing it we'd be shifting it to the right, but the x value shifts, if it's plus, it goes to the left. So here it goes to the left by pi over 2. So they're the sine and cosine are kind of the same too. They're just, they call this the phase. Cosine is pi over 2 out of phase with sine. Pi over 2 before, to the left of sine. So they're kind of the same function. They look the same shape, they're just shifted. So when we do modeling in chapter 19, we just use one of them. You don't need both, and so they just choose to use sine, because we can model a cosine with the sine. We just, shift it pi over 2. All right. This is going to be a long video. Did I say that? Okay, so now number 8. Use the unit circle to show that sine squared plus cosine squared equals 1. This is called a Pythagorean relation because you use a Pythagorean theorem. So here's our unit circle. And let's draw a new angle here. Okay, and here's our, so this is y, this is x. So there's our right triangle, right? And the radius is 1 in a unit circle. So x squared plus y squared equals 1. X squared plus y squared equals 1. But x is the cosine, so if this is theta, our angle is theta, the x value is a cosine of theta, so this is cosine of theta squared. The y value is sine of theta squared equals, I should say 1 squared, but of course 1 squared is 1, equals 1. So sine squared theta plus cosine squared theta is equal to 1. This is a lot of work, putting parentheses and doing it that way. So typically, right, you put the 2 right there, which means sine squared. If you put it like this, sine theta squared, it looks like only the theta is squared, right? So instead you put the 2 there, not there, because that just looks like it's sine of theta squared, just sine squared theta. It's kind of weird, but you get used to it. So if we write it like that, then this would be, I'm going to put the sine one first because that's what everybody does. Sine squared theta plus cosine squared theta equals 1. It's kind of weird because usually you go x squared plus y squared and the x is cosine. But everybody writes it sine squared theta plus cosine squared, like the sine comes first. Which is weird because, yeah, x usually comes before y and c comes before s. But sine, for some reason, gets to be the basic relation. It's because, again, it starts at 0. Most things start at 0 and it goes up. So sine kind of is considered the basic one, I guess. Like I said, we do all our modeling in chapter 19 with sine because it's kind of the basic one. It starts at 0 and goes up. That's what normal things do. All right. So that's where this comes from. It's kind of cool. Oh, and by the way, which you're going to see on the regular quiz, from this Pythagorean relation, again, it's called a Pythagorean relation because it just comes from Pythagorean theorem, you can get a bunch of other ones. Like, for instance, let's divide all of this by sine squared. Okay, if we divide this entire relationship by sine squared theta, sine squared theta, sine squared theta. Okay, so we divide all these things, divide both sides by sine squared theta. The sine squared here is that makes it 1. Cosine squared over sine squared is 1 over, tangent is sine over cosine. So cosine over sine is cotangent and it's squared. So 1 plus cotangent squared theta. And 1 over sine is, let's see, there's no co in sine, so it's cosecant. So 1 over sine squared is cosecant squared, so equals cosecant squared theta. So once we get this one, we can get another one, and we can divide it by sine squared theta to get another Pythagorean relation. So if you forget, this is like I said, which in calculus we use this a lot. If you forget them, you can just easily derive them from the basic one, which is some Pythagorean theorem. It's kind of cool. All right. Number 9, if sine theta is 0.3, find cosine theta. Okay, so let's draw our triangle. Sine theta is negative 0.3. Actually, no, let's draw a unit circle because that's what we always do. Sine theta is negative 0.3. So negative 0.3 is somewhere here. So cosine theta could be 2 things. It could be this angle or it could be that angle. So it could be all the way to here or it could be all the way to there. Or actually, cosine theta is the x value, right? So the x value will be something right here, positive, and then the negative one. So if we know one, we know the other one, because there's always going to be a positive one and a negative one. For the y value to be negative 0.3, there's 2 possible x values, but they're just, one's positive, one's negative. Okay, that's a pretty bad picture. but hopefully you can figure that out, right? So if here is negative 0.3, the y value, sine theta, the y value is negative 0.3. There's two x values that make that work, right here on the circle and right there in the circle. Okay, so we just got to figure that out. So again, it's a Pythagorean theorem problem. So what you do is you draw the triangle. I'll draw it the right way like this. Sine is the y value, so this side is 0.3. And we know that the hypotenuse is 1, so we need to figure out the x value. So what is this? So x squared plus 0.3 squared, and we could say negative 0.3, we're going to square it, doesn't really matter, equals 1 squared, or x squared is equal to 1 minus 0.3 is 0.09, 0.09 I think. So that is 0.91, right? 1 minus 0.09 is 0.91. So x squared is 0.91. So x is equal to plus or minus the square root of 0.91, which is not a pretty number. So we'll just leave it at that. So that's what the cosine is. So x is equal to that, which is equal to cosine theta. So if sine theta is negative 0.3, cosine theta, there's two possibilities. It could be plus square root of 0.91 or negative square root of 0.91. Okay, now what's tangent theta? Well, tangent theta is just sine theta over cosine theta. So we can just take those two values, negative 0.3 divided by, oh, which one do we take? Plus or minus, right? Could be either one. So plus or minus square root of 0.91. So basically that's plus or minus 0.3 divided by square root of 0.91. We can just leave it like that. I mean, we could get a decimal out of it if we wanted to, but that's okay. Okay, what is cosecant? See, cosecant is 1 over sine. So that's just 1 over negative 0.3. Yeah, and we could get a decimal out of that, but we don't need to. And what is cosine of pi minus theta? Okay, now if you remember, cosine of pi minus theta, and we worked all these things out, and you should have a chart somewhere where you wrote all these things down, like I do somewhere too, and I'm not prepared for this. This is one of the relations that we had. But cosine of pi minus theta, I believe, was negative cosine of theta. Gosh, I can't find my sheet right now. I wrote all this stuff down, so you'll have to check me on this. And that would just mean that we just take so then we know cosine theta is plus or minus square root of 91. So again, it's the same thing. It's plus or minus square root of 0.91. But if one of them was plus, then we take the minus. If one of those is minus, one of them we take the plus. Okay, so that's how that one works. So just using these relations. Okay, now moving on to this one. And I want to check on that really quick because it's bugging me. Let's see. So cosine of Yep, I got it right. Cosine of pi minus theta is negative cosine theta. Yep, that's right. Okay. Okay. Number 10, draw a triangle with hypotenuse equals 5 and the opposite equals 2. Okay, so let's draw a triangle. Hypotenuse, okay, as soon as you say hypotenuse, you know it's a right triangle. By definition, hypotenuses are only in a right triangle, so we can draw a right triangle. Hypotenuse is 5, and the opposite is 2. Okay, so it doesn't matter which one we call the angle. I could have called this one theta. But since I call this one it, then the opposite of theta is 2. Now, what is, okay, we know we're going to have to find the adjacent. So we know that 2 squared, let's call this is the adjacent, plus the adjacent squared, I'll call that A, equals 5 squared. 2 squared plus adjacent squared equals 5 squared equals hypotenuse squared. Or the adjacent squared is equal to 25, let's see, 25 minus 4, which is 21. So the adjacent is the square root of 21. Now it could be plus or minus, but here we just want the length of the sides, so we just say it's square root of 21. So the adjacent is the square root of 21. Now we can say what sine is. Sine is opposite over adjacent. That's what sine is, right? It's SOHCAHTOA, S-O-H, so sine is opposite to, tangent is opposite over adjacent. Sine is opposite over hypotenuse. We didn't need to do this yet. Yeah, that's why I put it first. Okay, sine, some old horse. The way I remember it is some old horse caught another horse taking oats away. Some old horse, sine is opposite over hypotenuse. So obviously it's 2/5. So we can just write 2/5. If you want to write 0.4, you can, but that's fine. Okay, tangent is opposite over adjacent. So taking oats away, or TOA, taking oats away, opposite over adjacent. And the adjacent we already said was square root of 21. So this is 2 over the square root of 21. And again, we could decimalize it, but it's okay to just leave it like that. And then, what is theta? Okay, so if we want to know what theta is, what this angle is, we have two options, and this is really chapter 20, which talks about inverse functions, but it's not hard to do. So let's just use tangent theta. So you can use either one, sine, cosine. Let's use sine because it's a nice, pretty number. So easier putting our calculator. So sine of theta is equal to 2/5, which is 0.4. So theta is the inverse sine of 0.4. And we want it in radians, so you put your calculator in radians and you'll get the right answer. So what you do is you just take the inverse sine, and usually inverse sine is second function. It's the one up above. You hit second first in your calculator. So you take inverse sine of 0.4, and I get 0.411 radians. So this is like, and it goes on forever, but yeah, about 0.41. So let's say 0.41 radians. So in this example, theta is about 0.41 radians. And we could get that in degrees too, but okay, so you have to use the inverse thing here. I think you guys have done that before. It's not, this part's not so hard. We'll do it a whole lot more in chapter 20. All right, did I say this is going to be a long video? This is a long video. Use the Pythagorean theorem on the unit circle to show that cosine pi over 4 equals that. Okay, so here, pi over 4 is 45 degrees. So we draw a 45-degree triangle. Okay, isosceles right triangle. So 45 degrees, which is pi over 4. And we know that this side is equal to that side. So this side is x, that side is also x, this is 45 degrees. Because if that's 45 degrees, right, this side is 45 degrees, and so those two sides have to be the same. And this side is 1. That's the unit circle, so unit circle, that's the case. Now, let's figure out what x is. So we have x squared plus x squared is equal to 1 squared, or 2x squared is equal to 1. X squared is equal to 1/2. X is equal to, and we want a positive number here, right? Because we just wanted the length of the side. So when we take the square root, we'll take the positive one. So it's a square root of 1/2, which is 1 over the square root of 2, which typically people multiply the top and the bottom by root 2 to get rid of the square root on the bottom. So root 2 times root 2 is 2, so on the top we have root 2 over 2, which we already said we know is like 0.707, goes on forever. Okay, so sine of cosine is adjacent divided by hypotenuse, right? So cosine of theta, say of theta, 45 degrees, or of pi over 4, same thing, is the adjacent, caught another horse, adjacent divided by hypotenuse. Hypotenuse is 1. The adjacent is x, which is this, which is root 2 over 2. And sine of pi over 4 is opposite over hypotenuse, but again, they're the same, right? The opposite and the adjacent are the same, so it's also root 2 over 2. That's the one place where they're the same. And also they're the same at on the other side, or way down here, they're the same. They're the same at pi over 4, and they're the same at pi plus pi over 4. They're both negative then. So the x and the y values are both negative then. Okay, that's number 11. One more piece of paper, but this is a hard piece of paper. Okay, number 12 is about the same thing, but now we're going to look at 60 degrees or 30 degrees. Either one, because you draw one triangle, you draw the other. But here's how you do this. It's kind of cool. This is like one of my favorite things. You draw an equilateral triangle. An equilateral triangle, you remember from geometry, all the sides add up to 60, right? Because it's 180 degrees in triangles, they all add up to 60. We cut it in half. Okay, that's really bad. They should be the same on both sides. Let's take this half. If we cut this angle in half, that's 30 degrees, right? Because we chopped it in half. So we took the half of the 60 and made it 30. This side is still 60 degrees. Okay, let's make it an equilateral triangle with sides of 1. So therefore, this side is 0.5, right? Because we chopped it in half. Again, this is very bad. This should be a little bit longer here, but whatever, you get the idea. This side is a half, this side is a half, because we chopped in half the equilateral triangle. Okay, come on, voice. Now we have a 30-60 triangle. So all we got to do is figure out the height. And then we know, oh my God. Then we know everything. We got to know the heights. Let's call that h. So we know Pythagorean theorem again. That's why I said use Pythagorean theorem. We have h squared plus 0.5 squared is equal to 1 squared. Or, see, 0.5 squared is 5 squared is 25, so 0.25. So h squared is equal to 1 minus 0.25. Put that on the other side, that's 0.75. Or we really want to use fractions here. So 1 minus a quarter is 3/4. Right, 1 minus, yeah, it's 3/4. So h, and we want the positive number, is equal to the square root of 3/4. Square root of 4 is good, square root of 3 is not. So that's the square root of 3 over 2. And we know that that's equal to 0.866, goes on forever. If you ever see 0.866, you know, wait, that's square root of 3 over 2. Okay, so the height square root of 3 over 2. Therefore, let's take the 60 degrees. Cosine of 60 degrees, which is pi over 3, because pi is 180, 180 divided by 3 is 60, is cosine is adjacent over hypotenuse, that's 0.5 over 1, so that's just 0.5. Sine of pi over 3 of 60 degrees is the opposite, which is h over hypotenuse. H is this, so it's root 3 over 2. And then if we look at pi over 6, 30 degrees, cosine of pi over 6, that's, let's look at the 31 now. Cosine is the adjacent. Now, the h is the adjacent, right? The 0.5 is the opposite. So cosine is h over 1. H is root 3 over 2, so that's root 3 over 2. So again, they just switch. Sine of pi over 3 is the same as cosine of pi over 6. They're both root 3 over 2. And then you can guess that sine of 30 degrees, or sine of pi over 6, is, we look at the 30 degrees, sine is the opposite, is 0.5, divided by hypotenuse is 1, so it's just 0.5, or 1/2. Say 1/2 here. Of course, it's 1/2, same thing. So, just from the equilateral triangle, cutting in half, using the Pythagorean theorem, we can figure out what sine and cosine of pi over 3 and pi over 6 are, which is what we used over here. So if you forget, wait, which one's root 3 over 2, whatever, you can just do this, and you can figure it out. Now, so we figured out this one, that this is root 2 over 2. The other way, of course, you can't forget, they get bigger, right? 0, 1/2, root 2 over 2, root 3 over 2. Root 3 over 2 is bigger than root 2 over 2, and 1. So, you know, you just have to remember the root 2, root 3, and divide it by 2. Okay, it's pretty cool. So that's how you figure those basic ones out. All right, now we have some problems that are similar to ones in chapter 17. Where you got to figure out, you know, using tangent and sine and cosine. Actually, it seems like they always use tangent. Okay, so here, this is like one we had before. So Rocky, I just said Rocky Reach Dam because that way you guys will get it right since you're familiar with Rocky Reach Dam. So it's 0.8 radians for a point in the Columbia River, and then you go further downstream. So of course you draw your picture. So here's the dam, here's the height, and this is 0.8, and then you go further downstream and it's 0.6. The angle gets smaller, right? So you go further, and we say we go 140, so this extra distance to here is 140, and then we draw that angle, and that angle there I said was 0.6, right? It's a smaller angle, so 0.6 radians. We want to know how high the dam is. So first we got to call this something, so let's call this x, because it's a good thing to call it. We need to know x, and then we need to know h. Well, we don't need to know x, we need to know h, but I think we got to figure out x to figure that out. Okay, so we have two things we don't know, x and h, which means we need two equations, but we have two things we do know. We need those two angles. So let's see, let's say tangent of 0.6, is equal to the opposite, h, divided by the adjacent, which is 140 plus x. So h divided by 140 plus x. And tangent 0.6, we got to use radians. Plug into a calculator, you can figure out what that is. That's a number. Let's do that right now. Make sure our calculator's in radians. 0.6 tangent. 0.684 looks like good enough to keep 0.684. And then we also have that the tangent of 0.8 is equal to the opposite of the adjacent is h over x. And tangent of 0.8 tangent is 1.029, about 1.03. Let's call it 1.03. Okay, those are two equations right here. Okay, these are two equations. We need to solve for h. We want what h is. We have two equations, but two things we don't know. We don't know h or x, which means we can do it, but it's some work. Let's see, let's do this. Let's put, this one's easy to solve for h. H is equal to 1.03x, 1.03x, and then we can take that and plug it into this one. So plugging into there, h is 1.03x divided by 140 plus x equals 0.684. Multiply both sides by that. I got to know 0.684 times 140. 0.684 times 140 is equal to 95.76. So 1.03x is equal to 95.76 plus x times 0.684 is just 0.684x. Put the x's in the same side, so I'm going to take away the 0.684 from 1.03. So 1.03 minus 0.684 is equal to 0.346. So 0.346x is equal to 95.76, or x is equal to 95.76 divided by 0.346, which is times 95.76. I get 276.76. Let's say 276. Let's say 277. So let's say 277. So this is 277 feet. Now we got to know what h is. But we know h is 1.03 times x. So h is 1.03x, which is practically x, right? Looks like they end up being about, these two things are about the same. But it's not exactly. So times 1.03, I get about 285. So it's about 285 feet. So that is our answer. It's always good to circle your answer because there's a lot going on here. So about 285 feet tall. Okay, so that's just using tangent, two equations, two unknowns, being careful with your algebra. And it should make sense, right? If this is 277, 140, 285, sure, that's a reasonable answer. If you get like 2 feet or something, it's like, okay, something's wrong. All right, last one here. Okay, so we're 8 and 0 and are swimming around a circular pool. It's kind of cool, of radius 40 feet. So we got to draw a picture. So here's our circular pool, radius 40 feet. So this is 40. And then Aiden starts at the southernmost point. So there's Aiden, southernmost point, and swims clockwise. Let's see, clocks go this way, so he's swimming this way. And then Owen starts at the northernmost point, right here, and swims counterclockwise, so he swims this way. And let's see, Aiden swims at 10 feet per second, So at 10 feet per second, that's his velocity, is 10 feet per second. And they pass each other in 8 seconds, so they crash into each other in 8 seconds. So they're going to crash into each other maybe somewhere around here. That's in 8 seconds. And find the x and y coordinates of ON after 30 seconds. Okay, so we're going to have to obviously do some math here. Okay, let's see. We want to find the x and y coordinates, which means we got to know omega and all that kind of stuff. Okay, so let's see. And we got to know everything for ON. Okay, so but if we know that they crash each other in 8 seconds, so we can figure out how far ON goes by knowing how far ADN goes. So in 8 seconds, the distance of ADN, so I'm going to say distance of ADN here, is velocity of ADN times 8 seconds, which is 10 times 8, which is 80, we're talking feet here. So okay, everything's, check the units, I think I made it so it's all feet in seconds, so we don't have to worry about it. So about 80 feet. He goes, what? Oh, okay, I'll just have to stop. Sorry, I got some technical difficulties here. Okay, so distance is, he goes 80 feet. So how far then does Owen go? So let's see, half the circle. Okay, so we just figure out he goes, if so that he goes, so this is okay, let me write down a picture. This is 80 feet, right? So what's left for Owen to go, that distance there? So half the circle is, let's see, a full circle is 2 pi r, so half of 2 pi r, which of course is just pi r. R is 40, so that's pi times 40, and 40 times pi is 125.66. Let's, okay, so let's put that 125.66 feet. Aiden goes 80 of those, so the distance of Owen, I'll just call it D, distance of Owen is 125.66 minus 80. So 45.66. So Aiden goes further. Makes sense. Aiden's a good swimmer. Maybe Owen's a good swimmer too. Sorry, Owen. So 45.66. That's how far Owen goes in 8 seconds. So we can figure out Owen's velocity. His velocity is distance divided by time, which is 45.66 divided by 8. So 45.66 divided by 8. I get about 5.71 roughly, so 5.71 feet per second, that's how fast he's going. Now we can figure out his omega, because V is equal to omega R, so omega is equal to, divide both sides by R, V over R. V is 5.71, his R is 40, the radius of the circle is 40, so 5 divided by 40. I get about 0.1426, let's say 0.143. So his omega is 0.143, and that would be in radians per second. So that's his omega. And now, oh, and we know his starting angle. He starts at the top. So his starting angle, theta 0, is pi over 2. And now we know everything we need. So we have our formulas that, you know, that we'll call the center of the circle 0, 0, which makes sense. I said use the center pole as the origin. So we have x is equal to r cosine omega t plus theta 0. Or in this case, x is equal to 40 cosine of 0.143 t plus pi over 2. And y is the exact same thing but sine. So we can just write down the y. It's 40, but you put a sine, and everything else is the same, 1.43 t plus pi over 2. That's where he is at any time you want. Now all we got to do is put in t equals 30 seconds. So plug in t equals 30 seconds, and then do a lot of calculator work. Okay, so 30 times 0.143 plus pi over 2. Okay, so 30 times 0.143 plus pi divided by 2. I get 5.861. So x is equal to 40 times the cosine of 5.86. Actually, it's 0.79. Say 0.08 is good enough, which is equal to, let's see, and the calculator has to be in radians. Again, this is radians, so you make sure your calculator is in radians. So take the cosine times 40, and I get 36.5 about. So 36.5. That's his x coordinate, and his y coordinate is 40 sine of that same number, 5.8608. And that is, see, 8608 sine, calculators in radians, okay, I'm good, times 40, so about negative 16.4, so negative 16.4 roughly. So if we look at our circle, x is 36.5, so his x value is right about here, y value is negative 16.4, so down here. So after 30 seconds, Owen is somewhere out there. 8 seconds he's there, keeps swimming around, takes him 30 seconds to get to about that point right there. All right, very good. Hope that makes sense. And on the regular quiz, I'll give you similar questions. You know, that you just got to figure this stuff out. Again, it should make sense. You look at our picture, they make sense, and so we're good. Okay, hope that helps. Bye.